Hi, I'm welcoming you all to this online platform, Unacademy. All of you know that Unacademy is the India's largest online learning platform. Now I'm welcoming you all to this beautiful online learning platform. Now we are happy to announce that Unacademy is going to providing support to the students who are going to writing the GATE and engineering service examinations. Now by gathering the top faculty, top educators in India, they are providing this support to them. Now about myself, I G Venkata. I have 16 plus years of teaching experience. So far I mentored more than 60,000 students for their GATE examination. At present I am pursuing PhD from JNTU Kakinada and my specialization is VLSI design. First we check how to get the Unacademy learning app. Just open your Play Store. In that Play Store, go to just you type Unacademy in that Play Store in search button. There you get the Unacademy learning app like this. Unacademy learning app like this. Then click on install button. It will install the Unacademy learning app into your device. Okay. Okay. Once installing the Unacademy learning app, just to open the Unacademy learning app, by opening this Unacademy learning app, there you can observe what are the different courses available in Unacademy. Different courses available in Unacademy and who are the top faculty, top educators handling the classes in that subject. Okay, you get that information. Here I am going to introducing few of the top educators who are working under Unacademy. Says he is the Tiwari sir, he is the IIT topper, and Ankit Goyal sir, he got twice GATE electrical stream all India top rank, and he is the gold medalist in IIT Indore. Next, Jain sir, he is the top computer faculty, and Jaspal Singh sir, he is ex-IAS officer. And here few more top educators available from different departments. Now we are happy to announce that recently we started two batches, for one for GATE 23 and other one is for GATE 2022. Now I am giving a brief introduction about that batches. There is a Ascend batch for GATE 2023. This is for mechanical engineering. This batch started from 8th February 2021. Okay, and Evolve batch for GATE 2022 mechanical engineering itself. This batch started from 8th February 2021. Here are the top faculty who are handling the subjects in this mechanical engineering. Next, there is a Ascend batch for GATE 2023. This time this is for civil engineering. This batch started from 8th February 2021. Next, there is a Evolve batch for GATE 2022. This time this is for civil engineering itself. And this batch started from 8th February 2021. Here are the top faculty. Whoever the faculty handling the subjects in GATE 2022, for GATE 2023 also, the same faculty is handling the subjects. And there is a Evolve batch for GATE 2022, computer science and information technology. Here are the top faculty from computer science and information technology. This batch started from 8th February 2021. And next there is a Ascend batch for GATE 2023. Sorry. For electrical engineering, this batch started from 1st to February 2021. Okay, here are the top faculty who are handling the subjects in this department. Next, there is a Ascend batch for GATE 2023 in Electronics and Communication Engineering. Here are the top faculty who are handling the subjects in that. And this batch started from 1st to February 2021. Next, there is a Evolve batch for GATE 2022 Electrical Engineering. Now, this batch started from 1st to February 2021. Okay, now there is a Evolve batch for GATE 2022. This time, this is for Electronics and Communication Engineering. Here are the top faculty who are handling the subjects in this. And this batch started from 1st to February 2021. Next, there is a Evolve batch for GATE 2022, and this is for Chemical Engineering. This batch started from 25th January 2021. So you must thank to Unacademy to provide such a beautiful facility to chemical engineering students, because at outside it is not possible to get a training for chemical engineering. Very rare conditions you get, hardly throughout India, hardly 1 or 2 locations you get the training for GATE for chemical engineering. For the students, it is not possible to move from their location to that point. So they provide this facility to the chemical engineering students. If any of your friends are in chemical engineering, please inform this one to them and please support them. And here are the top faculty, top educators who are working under chemical engineering department. Okay. Now, see, once we glance, what are the different engineering disciplines available in GATE, in Unacademy for GATE and service examinations. Okay. Now, first, mechanical engineering, electrical engineering, civil engineering, production and industrial, instrumentation engineering, computer science and IT department, ECE, electronics and communication engineering, and last but not least, chemical engineering. Okay. Now, in Unacademy you have 2 subscriptions. One is a plus subscription, other one is a iconic subscription. Okay, in plus subscription your classes are going to be handled by India's best educators. Interactive live classes, structured courses and PDFs, live tests and quizzes are available. Okay, live tests and quizzes are available. In iconic, same way, India's best educators will handle your classes, interactive live classes, structured courses and PDFs. Now, live tests and quizzes. You observe one thing, plus plan is the basic plan. Iconic plan take your preparation to the next level by providing a personal coach to you. Now, the purpose of providing this personal coach is personal test analysis. Whatever the test you've written here, the test is going to be analyzed by that faculty. The test is analyzed by that personal coach who are provided to you, and he will provide solution to that. Solution in the sense, by thorough study of your answer sheet, they will prepare where you are strong, where you are need more preparation, and where you are committing the mistakes. All those things they will prepare. Okay. That is the test analysis, personalized test analysis. From the knowledge of that, they will prepare a proper study planner to you, and respect to material they will provide to you. Okay. By following these things properly, any student can get success in the examinations. That is the intention to provide the personal coach. Okay. See, finally, personal coach get the more information about you and about your academics and about your study or preparation. Okay. Based on that, whatever the gaps you have to write the examination, they fulfill that gaps. Okay. to cover that gaps, we are providing a personal coach to you. But it outside, you will not get this facility. Okay. Now, we are going to check once the cost for each and every plan. In Plus plan, this Plus plan is available at a different subscriptions: 1 month subscription, 3 month subscription, 6 month subscription, 12 month subscription, like that, 18 and 24 months also. Okay, and the beauty here is you get EMI option also is there. EMI option also is available. No cost EMI. And so as a faculty, I am suggesting the students join minimum 1 year plan. Then in that 1 year, you can complete the preparation of all the subjects, and you can rewind the more subject more number of times, and you can write a sufficient number of tests before going to face the proper exam, final exam. Okay, and you can identify the gaps where you are doing mistakes and where you are lagging. You can fulfill those gaps, and finally you can go for exam with a full strength. That is the because of that you need minimum 1 year. That's why I'm suggesting the students, please join minimum 1 year. And the cost of this is 30,250. After using my code VROUT10, after using my code, here I'm writing that my code VROUT10, after using my code VROUT10, you can use this, you can get this by 27,225 rupees only. 10% discount you get by using my code. Okay, 27,225 rupees. Just if you compare this one with the cost of the transport to move from your home to the location where you are joining for training, for example, you join somewhere for taking the training, for the transport throughout the year, its cost is close to this amount, hardly 2 to 3,000 difference only. So just by paying the transport amount, you can get the facilities more than that by staying at your home itself. No need to move anywhere. Don't waste your time also. For transport in cities, minimum it takes 1 hour plus for going, and for coming 1 hour plus. Nearly 2 hours plus you are going to be wasting your time for transport. You can save that time by staying at your home itself. That 2 hours of time is sufficient to rewind the topics what we are going to be covering on that day. So my dear students, please think once of it and unnecessarily don't waste your time and your money. Okay. Sorry, stay at your home and stay safely, and continue your learning process by staying at your home itself by joining Unacademy. And there is iconic plan. Now here it is available only for 2 subscriptions, 12-month subscription and 24-month subscription. For 12-month subscription, its cost is 50,250 rupees. By using my code VROUT10, VROUT10, you get it by 10% discount. This is my code VROUT10. Using this, you get it by 10% discount. That is 45,225 rupees only. 225 rupees only. Okay. So EMI option also available here for this. And don't forget to use my code VROUT10 during subscription. Okay, and if you compare the cost of this one, this is the cost more or less equal to the amount what you are paying as a tuition fee to somewhere institute outside where you are taking the training for GATE. With this amount only, we are providing personal coach to you. His duty is to analyze your academic improvement, your improvement in the towards the preparation for your GATE examination. Okay, day to day they will update your knowledge, they update your performance. Okay, and any gaps are there, they will fulfill that gaps, and we make you ready for writing the GATE examination with a full stuff. That is the intention to provide the personal coach. Okay, my dear students, please understand and compare everything. Okay, don't lose anything. First of all, don't lose your time. Okay, stay at home and get the complete data what you are getting from by joining outside, what you are getting more than that information you get by staying at your home itself. Okay, and faculty will come and live sessions also is there, they will come live, and if you have any doubts they clarify the doubts. Okay, get the maximum benefit. And one more important thing, top educators, India's top educators are handling your classes. Please don't forget that. Most experienced faculty as well as who got top ranks in GATE and IES, they are going to handling your subjects. At the same time, who are the toppers in IITs, they are going to be handling your classes. Don't forget that. Okay, now don't waste your time. Enroll today by enjoy learning. Okay, thank you. Thanks for spending your time. Now we are moving to today's topic. Sorry. So today's topic is overview on PN-Junction Diode. So now I am requesting the students during live session, if you have any doubts, please post your doubts in YouTube. I will clarify your doubts here itself. Okay, no need to worry. Now, just a minute. Okay, overview on PN-Junction Diode. We start from how to create or manufacture a PN-Junction Diode. We start from that point. Okay. Now, PN-Junction Diode. PN-Junction Diode. First, students should know how to form or how to construct or how to compose a PN-Junction Diode. For that, first I have one doubt I am asking you. Please let me answer. I am taking a part of P-type semiconductor and some amount of N-type semiconductor. I am mixing both. Okay, mixing both, and I am preparing like this finally. Now my question is it behaves like a PN-Junction diode or not? Please give your answers in YouTube live. Is it behaves like a PN-Junction diode or not? Okay, just what I taken then is I taken some amount of P-type semiconductor and some amount of N-type semiconductor. I mixed both, and after that I prepared a material like this. Now is it behaves like PN-Junction diode or not? So I got one answer, that is Anand. So he mentioned no sir. Yes, you are correct Anand. This is no more behaves like a PN-Junction diode. It behaves like a semiconductor itself. Okay, now you may ask one thing, sir, which type of semiconductor it is? Which type of semiconductor it is? See here, based on the amount of doping what you added, it behaves like either intrinsic N-type or P-type semiconductor. For example, the amount of Na and Nd, that means acceptor impurity and donor impurity what you added both are equal amount, then it behaves like a intrinsic semiconductor. Next, if amount of Na is more, acceptor impurity is more compared to donor impurity, So once acceptor is more, then it behaves like a p-type semiconductor. If donor impurity is more compared to acceptor impurity, at that time it behaves like a, just to take intrinsic semiconductor. This is first intrinsic semiconductor. Step 1, intrinsic semiconductor. Intrinsic semiconductor. Okay, and after that intrinsic semiconductor, just mark a line at center for better understanding purpose. Now step 2 is, so that is step 1. Now step 2 is, this side dope with third group impurity, and this half dope with fifth group impurity. Dope with fifth group impurity. Okay, now once you dope it with the fifth group, third group impurity, it became p-type semiconductor. And once you dope with fifth group impurity, it became n-type semiconductor. N-type semiconductor. Okay, now in that p-type and n-type, fine. Now the third group impurities, once again I am repeating that the third group impurities what we are adding here is boron, aluminum or gallium. Because of large atomic size, we are not preferred India. Okay, now here fifth group elements what we are going to be adding is phosphorus, arsenic and antimony. Because of large atomic size, bismuth is not supported. Okay, so once you add third group impurity and fifth group impurity this side, this part behaves like n-type p-type semiconductor, and this region behaves like a n-type semiconductor. And one more thing, please, my dear students, so far junction is not formed. Junction is not formed. Okay. Next, now we are moving to third step. The third step is, just before you mention, this region is, so this is the junction diode. This is the p-type and n-type materials here we have. So this is the line we drawn to separate these to two halves. Now so just before you mention, after doping this region with third group impurity material, it behaves like a p-type semiconductor, and it behaves like n-type semiconductor. And we know how to represent the p-type and n-type semiconductors. We know how to represent the p-type and n-type semiconductors. Clear? Now p-type semiconductor means it should have so in p-type semiconductor, we know what are the different things present in that. In p-type we have negative immobile ions. See, negative immobile ions. Okay, and every negative immobile ion is going to provide one hole to you. Every negative immobile ion, that means we are adding, these are the impurity atoms what we are adding to this. Okay, is going to provide hole to you. So these are the holes. Okay, hole to you. And under intrinsic condition, it has few electrons and holes. These are the electrons, few electrons and holes at intrinsic condition, like this. Yeah. Now this is the way of representing p-type semiconductor. Already we discussed this one in semiconductors. Similarly, I am going to representing the n-type semiconductor. In n-type semiconductor, we have positive immobile ions, and every positive immobile ion is providing one electron to you, one free electron to you, like this. Like this. Okay, now here at intrinsic condition, it has few electrons and holes. So these are the holes it has, and electrons it has. And one more important thing we know, when a semiconductor doping is increasing in a semiconductor, majority carrier concentration increases and minority carrier concentration decreases. That is the very important point. You should keep it in your mind, please. Now finally, first of all, I am remembering one more thing to you. This is basically a single semiconductor. If you go back and check this, see, we taken single semiconductor. We taken single semiconductor here. This is the 0 step. I am taking intrinsic semiconductor. Single semiconducting crystal it is, first of all. Okay. So here it is a PN-Junction diode. Okay, now so this is the intrinsic semiconductor. First we are taking, basically it is a single semiconductor, and we mark a line on that. One side doped with the third group impurity, other side doped with fifth group impurity. After doping with the third group impurity, this region became a p-type semiconductor and this region became a n-type semiconductor. Now you observed one thing, in this region more number of holes and in this region less number of holes. Similarly, in n region more number of electrons and in p region less number of electrons. So I am writing that point. So my dear students, if anybody want, please take a note. In p side more number of sorry more number of holes and less number of electrons. Less number of electrons. Similarly, in n side more number of electrons, more number of electrons and less number of holes. Okay, so my dear students, just observe clearly here. That means there is a change in concentration with respect to distance is exist in this. So here more number of holes. If you compare the hole point of view, holes are more in number in p side and they are less in number in n side. That means there is a concentration gradient in terms of holes from p region to n region. Similarly, there is a concentration gradient in terms of electrons from n region to p region. Due to this concentration gradient, so finally we observed what we observed. It is observed that there is a concentration gradient. There is a concentration gradient exists. So once we have concentration gradient, immediately we can expect diffusion. We can expect diffusion. Okay, diffusion. So you can expect diffusion movement of charge carriers. Now the same thing is taking place here. Diffusion movement of charge carriers is going to taking place. Okay, so with the diffusion, see, with the diffusion, now holes are moving from p region to n region, p to n side, and electrons are moving from n region to p region. Now this is the diffusion movement of charge carriers. It results diffusion current we get. I diffusion. We get the diffusion current, and this diffusion current is moving from p region to n region, because always current is flowing in the direction opposite to the direction of movement of electrons. Here electrons are moving from n to p, that's why current is moving from p to n. So diffusion current is moving from p to n. This is the first event or first action takes place in a PN junction diode. So diffusion current is moving from p region to n region. Fine. Now I want to estimate this current is a low value or high value. See, for that, here holes in p region and electrons in n region are majority charge carriers. So this current is due to the movement of majority charge carriers. That's why this current is high value. So therefore it is a majority carrier current. Majority carrier current. Majority carrier current it is. Okay, now whatever the movement you mentioned, diffusion movement, now I'm going to implementing that diffusion movement in this plot. Okay, now so once a diffusion taking place, electron and hole are going to be recombined. Okay, now I will show that recombination here. A recombination is taking place. So whatever the hole in p region, this hole is moving this side. Okay, now See, now I am going to the fourth step. So this is the junction diode, like this we have. So my dear students, every diagram what I am going to be writing here is important. So this is the P region, this is the P region, and this is the N region. And in P region we have negative immobile ions, and every negative immobile ion provides one hole to you. Every negative immobile ion provides one hole to you. So at the time of intrinsic, it has some electrons and holes, like this. Similarly, in N-type, we have positive immobile ions. Every positive immobile ion provide one free electron to you. Free electron to you. At the same time, under intrinsic conditions, it has few electrons and holes, and those things are additional, like this. Now, just before we mention diffusion of charge carriers, once diffusion is taking place, this hole is recombined with this electron, and these two are recombined, these two are recombined with this electron, and these two are recombined. Okay, and these two are going to be recombined. Here these two are recombined. So next event taken place here is recombination. Recombination is the next action taken place. The first action we observed is the diffusion. The second action taken place at junction is recombination. Now after recombination, there is no free charge carriers across the junction. Now there is a line which is going to, there is an imaginary plane or line which separates both P region and N region. We call it as a junction line. Now across this line, there is no free charge carriers, because already the charge carriers which are available here are recombined to each other. Okay, now after that it became, now your diagram is like this. After this, after recombination, this is the diagram. Sir, every diagram is important. For your better understanding purpose, I am writing multiple diagrams. Okay, please take a note properly and get more benefit. This is P side and it is N side. Okay, now after recombination, here in this region you have only negative immobile ions. So negative immobile ions only. Similarly, in this side you have positive immobile ions. Positive immobile ions. Okay, now I am going to separating this plane with the remaining part. Yeah, the remaining portion here is, the remaining portion here is this part as usual, this part as usual. Here also this part as usual. Okay, now we have a complete work only in this region. Now see this. Now we observed finally a region across the junction taken place which is covered by only immobile ions. Only immobile ions, they are not moving. Okay, there is no free charge carrier. Now that region is called depletion region, and the width of that one is, let us take it as a W naught. Now this is called depletion region. Depletion region or space charge region. Depletion region or space charge region. Okay. Now you observed one thing. Once a space charge region is there, then it shows the dipole moment. That means it shows to be a negative immobile ions, this one side, and a net positive charge one side and a net negative charge one side. It results an electric field is directed from N region to P region. An electric field is directed from N region to P region. This is the electric field. Electric field. So after recombination, the result of this recombination is, therefore, the result of recombination is, result is an electric field is directed from N region to P region. From N region to P region at junction. At junction. Okay. Now, see, once an electric field is directed at a junction, so already we studied, if any electric field is there, it results drift moment of carriers takes place. Now due to this electric field, a drift moment of carriers are going to be takes place. So it results drift moment of carriers takes place. Now the next action taking place is drift. The next action taking place here is drift. Now we are going to next slide. Now just the number of that one is, fifth one is over. Now I'm going writing the sixth one. Okay, so this is your PN junction like this. This is the junction and this is P region and N region. Already we mentioned the depletion region at the junction. Okay, and this side negative immobile ions we have, and opposite side N side we have positive immobile ions. It results an electric field is directed from N side to P side. An electric field is directed from N side to P side. Okay, this is the electric field. So due to this electric field, we can expect drift movement of the charge carriers. So now I'm writing this P region also completing. In P region we have negative immobile ions. Negative immobile ions. Every immobile ion provides one hole to you. Negative immobile ion provides one hole to you. And as a electron as a minority charge carrier, and additional holes at the time of intrinsic. Similarly this side, positive immobile ions. Every positive immobile ion provides one electron to you. So with negative electron it provides Additionally, in this, few electrons and holes are available at intrinsic condition. What they are available? Now these are the holes like this. This is the representation, complete representation. Now electric field is directed at the junction from N region to P region due to this dipole effect at the junction. Now due to this electric field, we know that always electrons will move in the direction of electric field and holes will move in the direction of, electrons will move opposite direction of electric field and holes will move in the direction of electric field. Okay, so I am representing that one here. Holes will move, holes movement is in the direction of electric field, in the direction of electric field, and electrons opposite direction, direction of electric field. Just keep this point in your mindset. Now due to this drift moment, now the movement taking place here is a drift moment. Due to this electric field is N2P. Now holes has to be moved in the direction of electric field. That means holes has to move from N region to P region. So holes are moving from N region to P region. Similarly, electrons are moving from P region to N region. So due to this movement, drift current is flowing through the junction. I drift is flowing through the junction. Now the direction of this drift current is electrons moving from P to N. Now automatically current is from N to P. And one more thing, holes in N region and electrons in P region are the minority charge carriers. Therefore this current is minority carrier current. Okay, now here see this. Previously we get a diffusion current. The diffusion current is due to majority charge carriers and the diffusion current is flowing from P to N. Now what are the currents so far we observed? I am writing those two currents at one point for better understanding purpose. So far we observed here two currents, drift current and diffusion current. I diffusion is moving from P to N and I drift moving from N to P. This is the majority carrier current and this is the minority carrier current. Okay, you observed or not, both the currents are opposite in direction. One is moving from P to N, other one is moving from N to P. Okay, now with this movement there is some net current flowing through the junction, because this is the majority carrier current, more current, this is less current, minority carrier current. Okay, fine. And if you observe your junction, again there is a concentration gradient in your semiconductor. Basically it is a single semiconductor, don't forget that. Now in P region more number of holes, again in N region less number of holes. Similarly in N region more number of electrons and in P region less number of electrons. In N region more number of electrons. Again there is a concentration gradient. Due to this concentration gradient, again I am expecting diffusion movement of charge carriers. Now listen the points. The main points is completed, sir. Now what are the thing is happening now onwards is just a repetition of those sequence of steps. Diffusion, recombination, drift. Initially your diffusion current is high value because it is due to majority charge carriers and moving from P to N, and drift current is minor due to minority charge carriers, it is moving from N to P. Okay, now see once again, this is the last diagram. And this is P region, and this is N region. So this is the depletion region what is taken place here, and depletion region what is taken place here. Here you have a negative immobile ions, here net positive immobile ions, yeah, and this is as usual original case. Now we observed here, so an electric field is directed at junction from N region to P region. Electric field is taken place at junction, and before taking the electric field there is a drift movement, I drift, and I diffusion we have. Okay, now this is the direction of I diffusion, this is the direction of I diffusion. Okay, and similarly there is a I drift current due to this electric field, the drift current is flowing this side. This is the drift current, sorry, diffusion current it is, and this is drift current. This is drift current. Okay sir, this is the diffusion current, this is drift current. Initially this is high value, somewhere here your diffusion is initially, this is the diffusion current, high value, somewhere here is your drift current. And again we observed there is a concentration gradient exists in the semiconductor. Due to that concentration, diffusion movement of carriers takes place. It means holes will move from P region to N region, and electrons will move from N region to P region. This is the second level of diffusion. Already first level of diffusion is completed. Because of that only you got the diffusion current. You got the diffusion current here. Now, but this second level of diffusion is, the amount of diffusion in second level is less than the amount of diffusion in first level. Why? Because the second level of diffusion movement is opposed by the first level of drift what is taken place. With respect to drift, the carrier movement is simply opposite to the direction of carrier movement in a diffusion. Okay, because of that the diffusion in second level is less than the diffusion in first level. Okay, once a diffusion movement is decreasing, amount of diffusion is less, now diffusion current also going to be decrease. Now after diffusion, during the diffusion process, recombination of carriers is taking place. Once a recombination is taking place, the depletion width at the junction is also going to be increased. This is the junction after diffusion. After diffusion and recombination, this is the junction. Now here it is the depletion region width. Now this is the depletion region. This is the depletion region now. Okay, previously this is the depletion region, less amount, now it is increased. It means the negative immobile ions in the depletion region is going to be increased. More amount of ions in depletion region. it results the strength of the electric field which is directed at the junction is going to be increased. The strength of the electric field which is directed from N region to P region is increased. Strength of the electric field increased. Once the strength of the electric field is increased, the drift moment of the carriers is increasing. The drift moment is increasing. Okay. And one more thing, don't forget both the currents are opposite in direction. Now, in magnitude point of view, diffusion is current is now more and drift current is less. Again, there is a concentration gradient. Due to this concentration gradient, we can expect diffusion moment, but the third level of diffusion is less than the second level of diffusion. Why? Because there is a concentration gradient. That means due to this electric field, drift moment of the carriers is increased. Okay, now it results there is a decrease in diffusion current. Now diffusion current is decreasing. Now once diffusion is there, now recombination is taking place. Now it results an electric the depletion region width is going to be increased now up to here. Now this is the depletion region width. Once the depletion region width is increasing means the electric field strength is going to be increasing. Strength of the electric field is going to be increasing. Once electric field strength increases, drift moment is going to be increased. Now you observed here or not? Both drift and diffusion are going to be equal in magnitude here. Equal in magnitude. And due to opposite in direction, the net current passing through the junction is I net. The net current passing through the junction is 0. Then we said our PN-Junction Diode is under steady state condition. Then we said our PN-Junction Diode is under steady state condition. Okay. So students, please take a note of this diagram. This is very, very important. Okay, just a minute. Okay, next. Now, finally, under steady state, your PN junction diode seems to be like this. Yep. There is a, so we know that this is the P region and this is N region. In P side we have negative immobile ions. Negative immobile ions. Negative immobile ions in P side. Similarly in N side we have positive immobile ions. Okay, and we are calling this as depletion region. This is the depletion region, and this region is similar to regular TB type material what we have, like that, and this region also similar to that, and we are calling this as, we are calling it as depletion region. Now the width of this depletion region is W naught. W naught. That is the width of the depletion region. Okay. Now this is for your easy understanding purpose. I am completing this part also. Negative immobile ions provide hole to you. So here positive immobile ions, positive immobile ions provide free electron to you. Yeah. Next, and few electrons and holes as minority charge carriers. Here also holes as majority and electrons are minority charge carriers, like this. The semiconductor is like this. This is the depletion region. Already just before in our discussion we mentioned an electric field is directed from N side to P side. You should know that. What is the equation for that electric field? So far what are the things we discuss? For everything we are going to deriving an equation here. Okay. And one more important thing, with respect to this semiconductor, you know only amount of intrinsic carrier concentration, you know it, because initially you are taking intrinsic semiconductor, and after that you are adding Na on P side, you know this one. At the same time, amount of doping in P side, N side is Nd. Okay, just you know these three parameters, and few constants we are going to be using, that is a Vt equals to Kt by Q, you know that, and epsilon naught into epsilon r, you know this. Okay, and charge of the electron. Except this, the remaining things you don't know, so you need to derive an equation for the remaining things. Okay, now first I am going to representing the electric field equation. See, there is a Poisson's law. According to Poisson's law, we can write d square v by dx square equals to minus rho v by epsilon, where rho v is volume charge density. Volume charge density. The purpose of this Poisson's law, Poisson's equation, is to know the change in potential with respect to distance in a material or in a medium. Okay, change in potential with respect to distance in a medium or material. That is the intention to use Poisson's law here. And this is the volume charge density. In N side, we know that already we defined this volume charge density in semiconductors at the time of conductivity. Okay, we've written this simply NQ Okay, on n side for in n-type semiconductor. This is for n-type semiconductor. Okay, so our P whole concentration into Q for p-type semiconductor. Just I am writing basic equation, sir. Later after that we apply this one to this. Okay. Now, and we know one more. We know electric field E is equals to minus dV by dx. Minus dV by dx. Just substitute this E value here. That means dV by dx value here. Then we can write that equation is d square V by dx square is our equation. We can write it as d by dx of dV by dx. Now it is d by dx of minus E. Therefore, now our final equation is minus dE by dx equals to minus rho V by epsilon. This negative negative gets cancelled. Therefore, final equation for electric field is dE by dx is rho V by epsilon. Okay, rho V by epsilon. Now I am going to be doing little bit work on this electric field. Okay, so we derived an equation for electric field. dE by dx is rho V by epsilon. From this I am writing this one as dE equals to rho V by epsilon into dx. Now I am taking integration on both sides. Integration on both sides. Integral dE is E. And just before you written rho V value is n into q and n into p into q. Q constant, and in n-type semiconductor after doping amount available charge carriers are constant at a constant temperature, and hole concentration also constant in a semiconductor at constant temperature. That's where rho V is constant. Okay, and one more, sir, your semiconductor is uniformly doped. That is a default semiconductor. So rho V constant, E also constant, epsilon also constant, integral dx. So now it is rho V by epsilon into integral dx plus C. Now I am writing this is E equals to rho V by epsilon into integral dx is x plus C. This is the standard equation for electric field. Okay, now you observe this equation once. If I am going to take the plot like this, electric field E on y-axis, x on x-axis, it seems to be y is equals to mx plus C. So the electric field is a straight line. Straight line. Okay, simply it is a line equation. Okay, sir. Now based on the m, if m is positive value, then it gives positive slope, and if m is negative value, then it moves in a negative direction, negative slope. Okay, so that is the electric field. First of all, to get now C is a constant here. Now you get that value of C by applying boundary conditions. C is constant. it can be measured, it can be measured okay, by applying boundary condition, by applying boundary condition. By applying boundary condition, we can measure this. Okay. Now, I am going to first representing the equation for rho v. After that, I calculate the value of C. Okay. Now, I am going to previous one. So now I am going to plotting this. First, now I am going to rho v plot. Now I am going to rho v plot. This is the rho v volume charge density. X-axis. Okay, let us take this is x-axis. This is a junction is on y-axis. So this is the 0. Total depletion width is xp w naught. And this is the extension of depletion region. This is the extension of depletion region on p side. Now this point I am taking it as xp naught. And this is n side. Now I am taking it as xn naught. So once it is 0, this is going to be minus xp naught, that is the extension of depletion region towards p region, and this is xn naught, extension of depletion region on n side. Okay, now I am going to rho v. Here it is filled by negative immobile ions. Rho v value is therefore negative. Okay, so it is negative. And one more thing, it is negative fine. This is uniformly doped semiconductor. Uniformly doped in the sense, if we are taking a semiconductor like this, at this region, whatever the amount of impurity you are adding, in this corner and in this corner, at every point you are going to be adding amount of impurity is same amount. This side 10 power 14, this side 10 power 16 per centimeter cube impurity. Not like that. At this point, if you are adding 10 power 16, here also you need to add 10 power 16. At every point, at every corner per centimeter cube, you need to add that much amount of 10 power 16 per centimeter cube. That is the meaning of uniform doping. Okay, so because of that uniform doping, this plot is rho v plot is from here to here is constant value, and that too it is a negative one. So now it is like this. So it is constant. And from here to here it is electrically neutral because the net charge posed by this one is 0. No charge it poses, because whatever the holes we have and whatever the holes here you have, that holes is compensated by this free electrons available plus negative immobile ions available. That's why the net charge posed by this one is 0. So the amount of charge, a semiconductor is electrically neutral, we know that. This is the plot on n side, p side. Okay, I am going to similarly in n side. Similarly, n side also it poses the same, but it is a positive. Okay, so positive. It is 0 after this. Now at a junction, suddenly you observed it is shifting from negative to positive. Negative to positive it is shifting. That's why it is called abrupt junction. A sudden discontinuity, sudden change taking place at a junction. That's why this type of junction is called abrupt junction. Okay, abrupt junction. Or you observed or not, it seems to be a step size. It seems to be like a step or step graded junction. Now the value of this one is minus Na into Q, because the amount of doping here is, amount of immobile ions concentration is Na, charge is Q. Similarly here it is Nd into Q. This side it is plus Nd into Q, because amount of concentration of this immobile ions is Nd, charge Q. Okay, so this is the rho v plot. So finally rho v is going to provide three different values. Up to xp naught minus xp naught it is 0, and minus xp naught to 0 its value minus Na into Q, and from 0 to xn naught its value Nd into Q. After xn naught its value is 0. Now I am going to representing that by an equation. Therefore rho v value is, rho v is rho v is rho v is first minus Na into Q, minus Na into Q, second value plus Nd into Q, Nd into Q, and third value is 0. It gives minus Na into Q for x value greater than or equals to minus xp naught. Okay, sorry, greater than okay, or equal to minus xp naught, and less than or equals to 0. From minus xp naught to 0 its value minus Na into Q, and similarly here x value is greater than or equals to 0 and less than or equals to xn naught. Okay, so there is a sudden discontinuity x equal to 0. That's why I'm removing this equality here and equality here. At x equal to 0 there is a sudden discontinuity from negative to positive value, and this is the last case, 0 elsewhere. So the remaining case of x value rho v is 0. So far we know the plot for rho v as well as the equations for rho v from different points. Okay, now I'm taking this rho v value, I'm substituting this rho v in the equation of electric field, and I'm going to getting the perfect equation, complete equation for electric field. So this is the equation for electric field. E is equals to rho v by epsilon into x plus c. Now I'm going to using that. So here this is the equation we have. Electric field is rho v by epsilon into x plus c, and these are the different rho v values we have. Rho v is minus Na into Q and plus Nd into Q and 0 elsewhere. Okay, this is the case for x is greater than or equals to minus xp naught, greater than or equals to minus xp naught and less than 0, and it is this is the region 0 to xn naught, it is my Nd into Q, and it is elsewhere. Just a minute, sir. Now, just take the equation one after another. Now I am taking the first case. In a region where x is greater than or equals to minus xp naught and less than 0. In this region I am going to taking first. We know that in this region rho v value is minus Na into q. Just substitute this value in this. Therefore electric field E is equals to rho v is in that region minus Na into q. Na into q by epsilon into x plus c. X plus c. Now I am going to comparing this with line equation y is equals to mx plus c. Now this is the value which represents the slope. So from by comparison we can write slope m equals to minus Na into q. Na into q. So it is a straight line and it is starting from minus xp naught ending at 0, okay, and with a slope of minus Na into q by epsilon. By now these things I am going, based on these things I am going to plot the electric field. So the same location I am going to plot the electric field. Okay, so here we are going to plot electric field. This is the plot for electric field E. This is the x-axis. Okay, x. Now just I am extending these regions. So this is the point of minus xp naught and this is the point of xn naught. This is 0. Yeah. Now our electric field is minus xp naught to 0. Just before we observed that this is a straight line with a negative slope starting from minus xp naught and ending at 0, like this. This is moving with a slope negative this side and slope of this one is minus Na into q by epsilon. Okay, is it okay, sir? Now you observe this plot, and one more important thing, from here to here rho v is 0, so once rho v is 0, so electric field is 0. So I am finishing that part also. Here rho v is 0, electric field is 0 in this region also. Now at x equals to minus xp naught, electric field value is 0. That is the boundary condition I am going to using to calculate the value of C in that. So from plot, boundary condition is, so from plot, electric field plot, from electric field plot, at x equals to minus xp naught, electric field intensity E equals to 0. This is the boundary condition. I am substituting this condition on this. Therefore, E became 0, which is minus NA into Q by epsilon into x value is minus xp naught plus C. After simplification, I get the C value, that is minus NA into Q by epsilon into xp naught. See, my dear students, this negative became positive, net it is positive, some positive plus C equal to 0, therefore C is negative of that. That's it. Now, just take that value of C and substitute in this equation. E is equals to. Therefore, E became minus NA into Q by epsilon into X plus C value. So our C value is minus NA into Q by epsilon into xp naught. Now I am simplifying this. So from this I am taking minus NA into Q by epsilon into xp naught common. Then it became 1 plus x by xp naught. Therefore, our final equation for electric field is, therefore, electric field E is equals to minus NA into Q by epsilon into xp naught into 1 plus x by xp naught. This is the equation for electric field. Okay, this is the electric field in the region for x is greater than or equal to minus xp naught and less than 0. In that region, electric field equation is minus NA into Q by epsilon into xp naught into 1 plus x by xp naught. Now I am writing this equation at the plot. Yeah, here is we have a plot here. Now I am writing that electric field equation here. So the electric field what we get here is E, electric field E is minus NA into Q by epsilon into xp naught into 1 plus x by xp naught. This is the case value equation for x value is greater than or equals to minus xp naught and less than 0. In that region, this is the equation for electric field and this is the plot for it. Clear? Now next region, 0 to xn naught. So you observed or not, 0 to xn naught, your rho v value is nd into q. Now just I am going to using that, and this is our standard equation. So our standard equation for electric field is rho v by epsilon into x plus c. Okay, now I are going to second case, the region where 0 less than or equals to x less than 0 less than 0 less than or equal to xn naught. So in this region we know the rho v value. Rho v value is plus nd into q. Now just substituting rho v value here, therefore E is equals to rho v plus nd into q by epsilon into x plus c. Just you compare this with your standard equation, y is equals to mx plus c. Again it is a straight line with a positive slope. From this, by comparison, we can write slope m is nd into q by epsilon. Now see this, it is a straight line starting at 0 ending at xn naught with a slope of positive nd into q by epsilon. Now with this data I am going to complete the plot. It's completing its plot. See this? Yeah. So it is starting from 0 ending at xn naught, and its slope is positive, which is m equals to nd into q by epsilon. nd into q by epsilon, that is the slope of it. Okay sir. Now you may ask one thing, sir, why are you starting this plot from this point? Why it is started from this point? Why don't you start this plot like this? Like this, why don't you complete? Why don't you draw like this? See, this electric field is a continuous function because it is a single semiconductor. So rho v is a continuous function. Similarly, electric field also a continuous function. It will follow that. Okay. So because of that, I started from this point. And from this, you observed or not it gives the maximum value at this point. So the maximum value of that one is, let us, I am representing the maximum electric field is negative, it gives. That value is, let us, I am taking it as E naught. Okay, later we calculate or we do some workout on this maximum electric field. Okay, now I am going to derive the complete, and one more, minus nd into q by epsilon into x and naught. Take this c value and substitute here. Therefore, electric field is nd into q by epsilon into x plus c value. C is minus of nd into q by epsilon into x and naught. Just substitute the values, simplify this equation, which is, I am taking minus nd into q by epsilon into x and naught common, then it became 1 minus x by x and naught. So therefore this is the final equation for electric field in that region. So electric field is minus nd into q by epsilon into x and naught into 1 minus x by x and naught. So this is the equation for electric field from 0 to 0 to x and naught. This is for x value greater than 0 and less than or equals to x and naught. And take this equation right there at the plot. So now I'm going to writing this equation here at plot. Therefore this is also written as minus nd into q by epsilon into, just follow this. In place of NA we have ND, in place of xn naught we have xp naught, in place of xp naught we have xn naught into 1 minus, instead of plus minus because region changed, x by, instead of xp naught xn naught, that's it. This is for x value greater than 0 and less than or equals to xn naught. Okay, and default it is 0 elsewhere. Okay sir. Elsewhere. Okay, so So far we get the electric field. So electric field having three different values. Forget about 0. In depletion region, that means minus xp naught to xn naught, our electric field having two equations. Okay, and but from the plot it is observed that it is having a maximum value at x equal to 0, and we represented the maximum value is E naught. Maximum value is E naught. So the maximum value is E naught here. Next one is I am going to representing that maximum value E naught. So far we derived two equations for electric field. First one is minus Na into Q by epsilon into xp naught into 1 plus x by xp naught. Second one minus Nd into Q by epsilon into xn naught into 1 minus x by xn naught. So this is the region for x is greater than or equals to minus xn naught, xp naught, less than 0, and it is greater than 0, less than or equals to xn naught. So these are the two equations for electric field, but electric field is maximum, therefore E is maximum. Electric field is at a junction. This is the maximum electric field I am representing by E naught. This is at a junction, E naught at a junction. So junction in this sense, x equal to 0. So E became electric field is maximum at junction. So E at x equal to 0 is the maximum electric field, that is E naught. Now I am substituting x equal to 0 in these two equations. Let us take it is 1 and it is 2. In these two equations, I am substituting the electric field maximum condition. So E became E naught and x is 0. So I am doing the same thing. Now E is equals to E naught. First from this equation, E is equals to E naught equals to minus Na into Q by epsilon into xp naught into 1 plus 0 by xp naught. Now its resultant is, this is 0 by something 0. Now into 1, this one same value, minus Na into Q by epsilon into xp naught. This is the E value from equation 1. Similarly, I am doing the same thing from equation 2. E became E naught maximum at x equal to 0. Now it is minus Nd into Q by epsilon into xn naught into 1 minus 0 divided by xn naught. Now it is minus Nd into Q by epsilon into xn naught. See one thing, both are different. Here Na xp naught, here Nd xn naught, but both are representing the maximum value of a same function. Practically it is not possible a single function having two maximum values, not possible. If it is exist in this sense, those two values should be equal. Now I am doing the same thing. Now let us take this equation as 3 and it is 4. Okay, now therefore equation 3 and 4 both are representing the E naught. Both are representing E naught. Therefore 3 equals to 4. So our third equation is minus Na into Q by epsilon into xp naught equals to, fourth equation is plus Nd into Q by epsilon into xn naught. Okay, now I am simplifying this. Q epsilon, Q epsilon, sorry sir, it is minus sir, not negative, it is a negative, not positive. Now this negative gets cancelled. Finally we have Na into xp naught equals to Nd into xn naught. You can expect problems on this equation. So my dear students, please take a note of this equation. It is one of the important equation. And if you observe the plots what we drawn previously, here you are saying this is the depletion region with W naught, and you mentioned here it is, this is minus xp naught and it is xn naught. So W naught is xn naught minus of minus xp naught. That means we can write W naught is xp naught plus xn naught. Just I am going to using this. And we know, I'm moving to next page. So far we derived this equation. Na into xp naught equals to Nd into xn naught, and W naught is xp naught plus xn naught. Okay, xp naught plus xn naught. Now from this I'm going to writing xp naught is Nd by Na into xn naught. Just take this value, substitute here. Therefore W naught is xp naught value is Nd by Na into xn naught plus xn naught. Just simplify this, which is Nd into xn naught plus Na into xn naught by Na. Therefore W naught is, just take common xn naught in numerator, then it is Na plus Nd by Na. Therefore we can write extension of depletion region on n side xn naught equals to total depletion region with W naught into Na by Na plus Nd. Na plus Nd. This is the extension of depletion region on n side. Similarly, you get the value of, you get xp naught. Xp naught is W naught into Nd by opposite side doping xn naught Na, that means opposite doping, xp naught opposite doping Nd by Na plus Nd. So these are the two important equations. There is a chance of getting problems on this. Okay sir, so these are the values of xp naught and xn naught. And if you observe one thing in this, we know the values of Na doping we know, Nd also we know, but depletion region with W naught we don't know. Now we need to calculate the width of the depletion region. Okay, now I'm going to calculating that depletion region width. Calculation of depletion region. Calculation of depletion region. Region width. Just for your reference, here I am writing the junction with the depletion region, and this is P side, this is N side. Here is the depletion region with an N side and P side and N side. So it is filled by negative immobile ions, it is filled by positive immobile ions. Okay, now, and we draw, for your better understanding, I am going to writing electric field also, electric field plot also I am going to take in. This is a electric field E X, so this is also X junction 0, and these are the XP0 and XN0. This is XP0. Now the plot is like this. Already we draw this, we completed this. So this is the plot. This is the plot what we have. And one more thing, this is the depletion region with W0. Don't forget, this is the depletion region with W0. Yeah, and this is the maximum electric field E0, maximum electric field E0. Now clear. See, whatever the net charge here you have, net positive charge here you have, it gives a some potential Vp0 and it gives some potential Vn0. Okay, this contact potential, there is, this is P region and N region, both are contact here. So due to this contact there is a potential difference takes place. Now that is called contact potential. There is a contact potential. Generally we called it V0 or VBI, built-in potential also we called it. Its value is Vp0 minus, sorry, Vn0 minus Vp0. Sorry sir, this is a N region and P region. This is in P region Vp0, in N region Vn0. Now that is, so now it is Vn0 minus Vp0. Contact potential, it also called as built-in potential. Contact potential or built-in potential. Built-in potential. Okay, just keep it. Now I am moving my attention on electric field. So we've written our equation for electric field is minus dV by dx. From this I am taking dV is minus E into dx, and after that I am applying limits on this. Now just apply the limits to this. Now it is a dV. Now the limits should be in terms of voltage, and it is a dx. Now limits should be in terms of distance x. Now you go for either P side to N side or N side to P side. Both the cases you have to follow the same direction. Now let us, I am moving from P to N. P side potential is Vp0, N side potential is Vn0. Similarly, in P side depletion width is minus xp0 extension, because your electric field plot started from minus xp0 and it is ended with at xn0 in N side depletion region, xn0. Now see this. Now I am changing this, simplifying this. Integral dv is v, limits are vp0 to vn0 equals to minus of integral minus xp0 to xn0 into dx, sorry, into e into dx. Now we can write this one is simply Vn naught minus Vp naught. We know that this is nothing but our built-in potential or contact potential, what we defined previously. V naught is equals to integral minus xp naught to xn naught into E dx. And you observed one thing, sorry, here minus is there, minus, and you observed one thing, this is nothing but a slope of electric field, sorry, area of electric field from minus xp naught to xn naught. Area of electric field, area of electric field plot. Okay, so from minus xp naught to xn naught, just I am going to writing that equation. Now, so that V naught is, area is minus into, area of this one is half into, area of that one is half into base W naught into height E naught. Just substitute the values in that. Therefore V naught is minus half into W naught. So we have an equation. Okay, keep as usual W naught. Next, maximum electric field, we know it, minus Na into, you can take any one of that, minus Na into Q by epsilon or Nd into minus Nd. In terms of Na or Nd, choice is yours. Minus Na into Q by epsilon into xp naught. And already we defined an equation for, we represented an equation for xp naught in terms of W naught. Now I am replacing that value. Therefore V naught is minus into minus plus, so W naught Q by 2 epsilon. So Q by 2 epsilon into W naught, Q by 2 epsilon into W naught into Na into xp naught. Xp naught is W naught into Nd by Na plus Nd. Na plus Nd. Now this is a W naught into W naught square. So therefore V naught is Q by 2 epsilon into Na into Nd by Na plus Nd into W naught square. Okay, now take the remaining things this side and keep W naught. Therefore your W naught can be written as square root of 2 epsilon by Q into Na plus Nd by Na Nd into V naught contact potential. Now again I am simplifying a little bit. So therefore W naught can be written as square root of 2 epsilon by Q into Na by Na Nd, which is 1 by Nd. Similarly you get Nd by Na plus Na Nd, 1 by Na. So 1 by Na plus 1 by Nd into contact potential V naught. So this is the final equation for depletion region with W naught. So in this equation we know the everything, we know the value of everything except V naught. We know everything. We know 2 epsilon value, 2 Q value, Na we know, Nd we know, because we done the doping initially. Okay, but contact potential we don't know. So next session we start with derivation of contact potential. Okay, now thank you, thanks for your spending your valuable time with us. So next session we are going to complete the remaining part. Now don't forget to use my code VRAO10 during subscription. Don't forget to use my code VRAO10 during subscription. Just hit the bell symbol to get the notifications and join our Telegram group for latest updates on upcoming videos. And please subscribe our channel and please give your valuable comments on YouTube to strengthen ourselves, and that is the boost to us. Okay, and don't forget to join in Unacademy. So I am welcoming you all to India's largest online learning platform, Unacademy. Thank you very much. Thanks for your spending your valuable time with us. Thank you.